Properties of inverse trigonometric functions. So let's look at some of the properties of our inverse trigonometric functions now that we've found them. So here we have the inverse of sine minus x is equal to negative inverse of sine of x. So if we look at proving this, so we look here at our left hand side. Let y is equal to our inverse sine of negative x. So we can move this sign across. Our sine of y is equal to negative x in our range. Negative pi on 2 is less than y is less than pi on 2. So rearranging this, we are negative x is equal to negative sine y. So x is equal to sine of negative y. So we move our sign across again. Inverse sine of x is equal to negative y. We move our negative sign across. Y is equal to minus inverse sine of x. So therefore, we've proven that our inverse sine of negative x is equal to minus inverse sine of x. Our next property involves our inverse cosine here. So inverse cosine of minus x is equal to pi minus inverse cosine of x. So looking at proving this one as well. If we set y is equal to our inverse cosine of minus x from our left hand side, then we move our cosine over. Cosine of y is equal to negative x in our range. 0 is less than y is less than pi. Rearranging this, we get x is equal to minus cosine of y. So we know from before that this is x is equal to cosine of pi minus y. So we're going to move our cosine across, so our inverse cosine of x is equal to pi minus y. We move our pi over and our y. Y is equal to pi minus the inverse cosine of x, which is our right hand side. So here we've proven our inverse cosine of negative x is equal to pi minus the inverse cosine of x. And our third property here, we have our inverse tangent of negative x is equal to minus our inverse tangent of x. So looking at proving this, we look here again at our left hand side. We let y equal inverse tan of negative x. We move our tan over. Tan of y is equal to negative x in our range. Negative pi on 2 is less than y is less than pi on 2. Rearranging this, we get x is equal to our negative or minus tangent of y. So here our x is equal to our tangent of minus y. We move our tangent over. We have our inverse tangent of x is equal to minus y, and we move our negative sign over. Y is equal to minus inverse tangent of our x. So therefore, this is our right hand side, and we've proven our inverse tan of minus x is equal to minus inverse tan of x. And we have one final property here. We have our inverse sine of x plus our inverse cosine of x is equal to pi on 2. So if we look here, we're going to let y is equal our inverse sine of x. So we move our sign over. Sine of y is equal to x in our range. Negative pi on 2 is less than y is less than pi on 2. Then we can substitute our y back into our original equation here. So y plus our inverse cosine of x is equal to pi on 2. So our inverse cosine of x is equal to pi on 2 minus y. We move our cosine over. X is equal to cosine pi on 2 minus y. So if we substitute these in, our inverse sine of y plus our inverse cosine of cosine pi on 2 minus y is equal to pi on 2. So y plus pi on 2 minus y is equal to pi on 2. So these will cancel out. Pi on 2 is equal to pi on 2. Therefore, we have our inverse sine of x plus our inverse cosine of x is equal to pi on 2. So now we have a few examples. We want to show that the inverse cosine of minus 1 here is equal to pi minus the inverse cosine of 1. So if we look at our left-hand side, we're going to say let y equal our inverse cosine of minus 1. And our inverse cosine is equal to pi of minus 1 is pi. Then we look at our right-hand side. We're going to say let z be pi minus our inverse cosine of 1. Here, so we look at this, we have pi, our inverse cosine of 1 is equal to 0, pi minus 0. So this is equal to pi. So here we have y is equal to z, or our left-hand side is equal to our right-hand side. So we know here cosine, our inverse cosine of minus 1 here is equal to pi minus our inverse cosine of 1. For our next example, we want to show that our inverse cosine of 4 on 5 plus our inverse cosine of 4 on 5 is equal to pi on 2. So we're going to say let y equal our inverse cosine of 4 on 5 here. So we move our sign over, sine of y is equal to 4 on 5. And we say, well, our second part here is our inverse cosine. So we say let z equal our inverse cosine of 4 on 5. Here we move our cosine over, cosine of z is equal to 4 on 5 here. So if we think about this, we know this fits into our 3, 4, 5 triangle. If we have y here, sine of y here is opposite over hypotenuse 4 on 5. And now if we think about our z, our cosine of z is 4 on 5. If we put here, our adjacent is 4, our hypotenuse is 5. So both of these angles exist within our right angled triangle. And our right angle is taken out here. So we know, well, our angle y plus z must equal 90 degrees here. And 90 degrees is pi on 2. So we know, well, here y and z is equal to pi on 2. And here's our y is our inverse sine of 4 on 5, and z is our inverse cosine of 4 on 5. So now we say, well, our inverse sine of 4 on 5 plus our inverse cosine of 4 on 5 is equal to pi on 2.